The next lesson, 5.4, will deal with climate change and public health. And in this section, I want to go over three general topics. There are 7 principles of climate change I want to review, some public health impacts of climate change, and then how to control carbon dioxide emissions. So let's begin with the 7 principles. Well, the first one is well known to everybody, the greenhouse effect, and it's important to understand that we can't really change this. This is a phenomena of the Earth's atmosphere, and whether it's the atmosphere or a greenhouse or an automobile, we all know the ability of heat to be captured inside these containments. You could read about some of the details in the particular slide. So again, we cannot stop the greenhouse effect. However, we can control what makes the greenhouse effect, what exacerbates it, and that's essentially the greenhouse gases. These are all greenhouse gases. They're basically molecules with unbalanced atoms in it. Water vapor is a greenhouse gas, but no one talks about it because we can't really control it. Likewise, carbon dioxide is in the news a lot, methane, and some of the other ones which are of less concentrated quantities in the atmosphere. So we never talk about ozone or nitrogen dioxide because there's just very little of it in the atmosphere. So what we have is these molecules absorb the radiation and retain it, convert it into infrared, and retain the heat. Methane, as you see, is very significant these days. Not only does it come from animals, and here you could see some details on the volume of methane produced by cows, but it also is coming from fracking, hydraulic fracturing. And the interesting thing today is that the arguments on fracking seem to go that methane is being produced and released into the atmosphere, and therefore fracking is becoming a greenhouse, global warming, climate change issue. Very interesting how that's evolved. But again, we can't control methane gas. The next effect is the albedo effect. You all know about this. You've walked on the sidewalk where it's a cool surface and then a black asphalt where it's very hot. Perhaps at the beach you've experienced that. And basically the darker something is, the more it will absorb radiation and generate heat. This is very important and is used for understanding the changes in the icebergs and Arctic areas. Not only does snow, white material, reflect a great deal of sunlight, but as it melts, it's releasing a surface area, Earth, which is very dark. So the resultant surface is actually high albedo, a very low albedo, low reflectivity, as opposed to the snow. And this is thought to be especially significant in an area like Greenland, where large parts of ice sheets are melting away, exposing dark land, which is then causing additional heating. So this is the albedo effect. We can change this because many roofs in buildings these days are painted white to produce a smaller signature, a smaller heat island signature. And more surfaces are light colored. And you all know about this. Wearing light colors in the summer tend to keep you cooler. The next concept is water density and volume. And let me ask you, when that iceberg on the right melts, is that water level going to go up or down? Well, another way to look at it is this way. If the ice in this glass filled with water melts, will the glass overflow? And I think you all remember from your basic physics that no, the volume of ice is greater than the volume of water, meaning that's why ice floats. So when that ice melts, the level actually will go down. So we are wondering, well, since there's so many icebergs, why is the sea level rising when we're getting warmer climates? Well, we have so much quantity of ice above the sea level that it far exceeds the buried icebergs out in the ocean. Some of these are measured in miles of ice in Antarctica. And when this starts melting, it does raise sea level. However, the absolute most important principle of climate change is climate sensitivity. This is the relationship between atmospheric change and temperature. So the question is, as carbon dioxide increases, how much does air temperature increase? So if carbon dioxide doubles to a level of 560 from years back, what will be the subsequent rise? And this is the big controversy. There are many unknowns in climate change science. However, this is probably the most important, because if we use a number of 2 degrees centigrade as opposed to 5 degrees centigrade, we'll get vastly different effects. And we do not know this number despite numerous measurements on the planet of temperature. And here you see the increase since 1940, 1950, the steady increase in the temperature of the planet. Is this anthropomorphic? Well, it's a big debate, but of course I think it's quite obvious that we have impacted the climate on the planet. I think to say anything other than this is somewhat naive. The question is, how much more impact will there be, and how fast is this rising, and whether our activities are really enough to reduce it. So this is the big debate, mostly around climate sensitivity. As regards anthropogenic versus natural emissions, well, we can control the anthropogenic sources, whether it's factories, emissions, or automobiles, and we're doing a better job of that these days. But things like volcanoes, swamp gas, forest fires contribute volumes and volumes of carbon dioxide in the environment that we cannot control. But the reality is that that's going to happen anyway, so we might as well control what we can and not worry about the planet adding to its additional volume. The last concept, very interesting in environmental science, is sinks. The whole idea that something will end up somewhere. Everything has a sink, whether it's mercury, lead, carbon dioxide, or even freon gas. In this particular case, the sink for carbon dioxide is in oceans, soil, and plants. So the question really becomes, can the planet absorb this? As we increase carbon dioxide, will more plants grow? Will they speed up? Will the oceans absorb more carbon dioxide? What are these chemodynamics in place? Again, this is a bit of an unknown. We're not sure how fast the planet can adjust to these atmospheric changes. The next topic is public health impacts of climate change, and I just want to present you with a number of possible changes. And here we see not only in changes in amount of precipitation and where rain is falling, but the whole idea that we're getting more extreme weather and that this may be climate related. Though it's a controversial science with no clear yes or no, there is strong belief that the increase in extreme weather may be related to increases in temperature changes throughout the planet. However, as I let you read the rest of these impacts, I want to say that it's all about change. People are afraid of change. The stock market is afraid of change. Politics is afraid of change. And any change from the status quo is scary and undesirable. So we never hear about the positive impacts of climate change. Is it possible more land will become fertile and more water will be available in arid areas? Or is it all just negative? Well, I think it's wrong to think that it's all going to be negative. There's probably some positives there. So why is the debate so negative? Again, changing from the status quo is frightening and unknown, and therefore people are scared of it. I just wanted to add that little bit of wisdom to you. The last topic is managing carbon emissions. How is this done today? Well, carbon dioxide reductions can be done on a demand-side approach. What is that all about? You, the consumer, is told to use less. Buy a high energy saving device, a refrigerator, change your lights, do this, shut your lights, buy more light shades, etc., etc., etc. We're all told to stop using so much electricity. That's a demand side approach, and it works, of course. However, what about the suppliers? What about the people making energy? Shouldn't they be involved in this? And that's why we have a supply side approach. I think the solution to carbon dioxide emissions, of course, is a dual approach. Companies generating energy have to reduce its impact, reduce the carbon dioxide that's produced from it, maybe wind farms or hydraulic or geothermal. And likewise, we as consumers have to do our share. But I do get a little annoyed when everything seems to be our fault, meaning people's fault, and not allowing industry to be innovative. It's got to be a balance. Let me show you this example, which is rather fascinating, and it's actually old. It's 2008. Here's a building, and under normal operations, you see we have at 6 a.m. in the morning, energy use in this building goes up as measured by kilowatts, and it goes up and up and up. And then at 12 o'clock, we see something happening. What happened at 12 o'clock? The utility called the building and said, please implement your energy saving plan. And the building at 12 o'clock immediately reduced its energy to the red line, saving all that yellow in energy. What did they do specifically? Well, they basically eliminated escalators every other floor. They reduced the number of lights in a classroom. They reduced various elevator banks. So instead of having 5 elevators running, they had 2 elevators running for this time period. The key here is that the energy company needed the electricity desperately, and they reimbursed this building for the energy they saved. So this is what's called a smart building, and it's part of that whole sustainability and green building topic we spoke of earlier. Many buildings are participating in this program so that when we have high peak energy demands, buildings are immediately told to go into Plan A and reduce their energy. So if you go into a building in the middle of a hot summer day and the lights are dimmed and the elevators aren't all working, now you'll know why. So how else are we regulating carbon? Well, there's 3 basic approaches. The first is a tax. Well, no one likes a tax, but the basic concept there is you can release so much carbon dioxide. If you go more than that, you pay more, and it's progressively a bit of a penalty. It's not popular, and it's not going to happen. Cap and trade is something people have been talking about for many years, and the thought here is that every country gets an aliquot of carbon dioxide emissions based on industry and population. Next, if you go beyond that point, you need to buy some from people that have it available. So it's a cap and trade system, internationally based. The rich countries generally are not in favor of this. The low and middle income countries are thrilled with it because they'll probably be making a lot of money on this, given their energy demands are much lower per capita than the high income countries. But it doesn't look like cap and trade is happening anytime soon. So what did the EPA do? They essentially are regulating carbon as an air pollutant. Yes, carbon dioxide, which is not toxic, is being regulated as an environmental poison, not necessarily a human health poison, setting emissions on how much carbon dioxide a company can release. And lastly, and that's it for this particular module, Module 5.4, Climate Change and Public Health. I did race through some of these topics, and I encourage you to do a little research in the book as well as online and learn more about it, especially the impacts of climate change. And with that, I'm going to leave you with this funny cartoon, which I sort of like.